In this video, we discuss about the disk scheduling in an operating system. First, what is meant by disk? That is the important one. Here, each disk has a queue of jobs waiting to access disk. First one is read job, second one is write job. There are two types of jobs are available. First, read the jobs and allocate the memory space for the jobs and write the jobs into the memory space. And then each entry in queue contains the following pointer to memory location to read write from to, sector number to access, pointer to next job in the queue. OS is usually maintain this queue. So this one is there are two jobs are mainly read and write into the OS. So the disk is very useful for read the job and allocate the free space to the job and write the job successfully. Another one is disk queue. Here the disk queue, in this disk queue, these are all the disk queue available here. First of all, in disk there are entry 1, 2, 3. The entry 1, entry 2, entry 3 is different from the jobs. Job 1 is entry 1, job 2 entry 2 and job 3 is entry 3. Each entry he has the sector X and the memory and next entry. First entry is finishing means the entries go to the next entry and the next entry is also have the sector name. For example, first one entry has the sector X means second one is sector Y and memory pointer is 1 go to the next entry. And then after finish the two entry, we jump to the entry number 3. The entry 3 also the sector name is available. For example, entry 1 has X, entry 2 is Y, entry 3 is EZ. And also each separate memory pointer and memory space. After finishing the 3, you go to the next entry. So these are all the entries. The entry is different from job. Each job has each entry. Each entry has 3 sections. One is sector, memory and entry point. So these are all the jobs available and go to the disk and disk is allocated the 3 jobs and to perform a project. Here first type of disk scheduling is FIFO, first in first out. For example, first in first out is a ticket counter. First do accesses in the order in which they are presented to the disk. This is very fair to processes. This is very simple to implement. We compare to other model, FIFO is very easy and very easy to understand and very simple to implement. Approximates random accesses to disk, gives rated average latency for every read will have large average seeks between each accesses. Not a good policy. So here FIFO first in first out is the very easy and very simplest one. This is the first method in disk scheduling. The example is the in a ticket counter, first person is buy the ticket and go to the hall. So this is the first in first out concept. It is very simple and easy to understand. This is the diagram. First of all, reference string 535 to 14, 12, 21, 3, 9, 22, 20 something. So the first string is 5 and then 35 to 14, 12. Okay, there is no problem. First string go to the first level. Another string another level and last string go to the last only. So here the calculation the distance is total is 124. In FIFO, recording the accesses to the disk could greatly reduce the seek distance. Seek distance is a seek time and to put close accesses next to each other in the queue. In disk scheduling, multiple requests to disk will arrive while one is being serviced and reduce the average seek time by intelligent scheduling accesses. Another one is SSTF. SSTF means shortest seek time first. It is different from the FIFO. In first in first out, the first string is go to the memory space and allocate the memory space. But in SSTF, it is based on the shortest time of the process. Okay. When a new job arrives, calculate its seek distance from the current job, place it in disk queue accordingly. Service in the next closest access when the current job finishes. Here the example of SSTP diagram is here. Here there are 10 string is available 5, 35, 2, 14, 12, 21 something. Here the which is the shortest job means here the 3 is the shortest job. So we allocate the 3 first. Assigned one is 5. Sorry. First one is 2 also available here. So 2 is very shortest job. First one is 2. Second one is 3. And then 5, 9, 14. 12, 14. And orderly go to the last one is 35. So the calculation is 35. It is the different from the SSTF and FIFO. In FIFO, you see the calculus time is 124, but in SSTF we have the 35 minutes only. So these are all the difference from the FIFO and SSTF. Here the special features of SSTF is to provide the substantial improvement in seek time over FCFS. Only one major issue is available here, that is means starvation. If some accesses are now fair and in disk current access, jobs are constantly arriving in a real system. So the starvation is the only one major issue. Another one is elevator algorithm. Already we have the FIFO, SSTF, priority scheduling, round robin method. But here we use the elevator algorithm, so one of the similar to SSTF. First one is only one major difference means what the next job scheduled in closest to current job, but in one particular direction. But the direction are put toward the hint of the list. This algorithm, elevator algorithm, is used to goes up first and then comes back down. This is the elevator algorithm reference string. The same string is available 5, 32, 2, 14, 12 something. But the calculation is different, 63. This algorithm is useful for the disk scheduling to allocate the memory space for a particular job. Here why we use the elevator algorithm means it avoids the starvation, because we already seen that in SSTF we have a major issue, that is starvation. So this elevator algorithm avoids the starvation. So we use the algorithm for the disk scheduling, and it also provides a very good performance over than the SSTF. Elevator algorithm given the very good performance. It has the major issue on fairness. Fairness is a major issue. And the jobs in the middle of the disk get serviced twice as much as jobs are at the ends. This is the one-way elevator algorithm. Exactly like elevator algorithm except scheduling in one direction. Example, elevator always go up only one way only. Another one is one long seek after finished going up is back to the beginning. The back to the beginning is very useful for detect some error available in the path. This long seek is done infrequently. This is the diagram for one-way elevator algorithm. Only one way is available, one direction only available here. Here the calculation of the seek distance is 64. It is different from SSTF because this is the overcome the drawback of the starvation. So we use the one-way elevator algorithm for find the path. Okay, thank you. We see in the next session. Thank you so much for watching. Thank you.